today we are going to start with modular arithmetic. This is a part of number theory and which is very common for the aspirants preparing for Maths Olympiad. But we will use this. We will learn first and then we will use it in problems involving finding remainders. Though we have already done finding remainders in binomial theorem chapter. But if we know modular arithmetic, it will help us a lot to reduce the time in solving remainder type problems to a large extent. So that is why we are interested for this chapter, and we will learn the chapter thoroughly to that extent which we need, and we will apply it in the problems, right? So let's start today's class. Modular arithmetic, actually, what does it mean? Suppose if I say that when 9 is divided by 4, the remainder will be, in modular arithmetic, as I told you, it primarily deals with finding out the remainders. So we are interested in that. When 9 is divided by 4, the remainder is 1. So this thing we write in this way, that 9 is congruent to 1, congruent to 1 modulo 4. And how we write this? 9 is congruent to 1 modulo 4. It means that when 9 is divided by 4, the remainder is 1. Or in other words, you can say that when 1 is subtracted from 9, it is completely divisible . It is completely divisible by 4. That's the meaning. Is it clear to all? Have you understood this? Let me take one example. Say when 11 is divided by 7, what is the remainder? The remainder is 4. So how will we write this? 11 is congruent to 4 modulo 7, right? Similarly, we can think in this way. When 9 is divided by 7, the remainder is 2. So we can write 9 is congruent to 2 modulo 7. Okay, have you understood this now? Now let us see how it helps in finding out the remainder when the exponent is very large, as we have dealt this thing in binomial theorem. So for that, we have to learn some properties. What are the properties? Let us say A is congruent to B modulo M and C is congruent to D modulo M. Okay? Now, we will always take the reference of these two and we will establish the properties. In this case, if we add 11 plus 9, and this thing will become 4 plus 2 modulo 7. Question is it correct? Absolutely. Because this gives us what? 26 modulo 7. That is, when 20 is divided by 7, the remainder is 6. That is our first property, which is the addition property. It states that if A is congruent to B modulo M and C is congruent to D modulo M, then A plus C is congruent to B plus D modulo M. This is the first property. In our terms, we can say that we can add the corresponding sides. In this way, we can remember. Okay, now let me just subtract this two. What we are going to have? 11 minus 9 is congruent to 4 minus 2 modulo 7. The question is it correct? 2 is congruent to 2 modulo 7. Is it correct? Absolutely it is correct. When 2 is divided by 7, the remainder is 2. So the second property, which is the subtraction property, what we have learned is A minus C is congruent to B minus D modulo M. Is it clear? What else? Can we multiply both sides? Let us check. 11 and 4 is congruent. 11 is congruent to 4 modulo 7 and 9 is congruent to 2 modulo 7. So if we multiply, we are going to have 11 into 9 is congruent to 4 into 2 modulo 7. But my question is it correct? So it's 99 is congruent to 8 modulo 7. But when a number is divided by 7, the remainder cannot exceed 7, right? Therefore, the remainder in this case will be 1 modulo 7, correct? But my question is it correct? Absolutely. When 99 is divided by 7, the remainder is 1. Hence, this property is true. So the third property states that you can multiply the corresponding sides to have AC is congruent to BD modulo M, right? Okay, what else? Now let us see, we are having 9 and 2 are congruent modulo 7. So now if we raise its power to 2, so it will be 2 square. Let us say, let me check whether this property holds or not. 9 square, I have raised its power to 2. So 9 square is congruent to 2 square modulo 7. But my question is it correct? 9 square is 81. When divided by 7, the remainder is 4. Absolutely it is correct. Why? Because 11, 7, 77. So remainder will be 4. So what we have learned, even if you raise its power to higher exponent, still this property holds true. That is, the fourth property, which is a very important property, is that whenever we raise its power to k, k is a natural number, then a to the power k is congruent to b to the power k modulo 7. This is true. Is it clear? And last but not the least is that whenever a number is divided by some number which is less than this number, what I'm saying is, suppose if I divide any number by 7 and you are dividing, that is the dividend is less than 7, then the remainder is always that dividend. Isn't it so? When 3 is divided by 7, the remainder is 3. When 4 is divided by 7, the remainder is 4. Any number which is less than 7, the remainder will be that number. So this property we can say that your A and A is always congruence modulo M until A is less than M. If A is less than M, then A is congruent to A modulo M. Okay? So these are the 5 properties that we have to remember for finding out the remainder problems. Okay? Okay, let me take one example. See this question. Find the remainder when 2 to the power 100 plus 3 to the power 100 plus 5 to the power 100 is divided by 7. Since this is the first sum that we are doing, what I will try to do, I will simply copy the properties that we have written in the previous page in this page, so that we can take the reference quickly. So these are the properties that we have learned. So now, let me start with 2 to the power 100 first. What I'm trying to do is, when 2 to the power 100 is divided by, say, 7, we are interested in finding out what will be the remainder. So always start this kind of problems with the fifth property. We will say that 2 is congruent to 2 modulo 7. Right? You see, our prime task, you have to understand how we do this kind of sums. Whenever the exponent is too large, all we do is we try to bring the remainder as 1. That's our only objective in this kind of problem. You find out the remainder as 1 and do whatever is needed for that. Okay? So in this case, and you know why it is so? Because the moment you get the remainder as 1, now I can raise its power to any level, and your remainder will still be 1 in that case. And that is why we are interested in finding the remainder as 1. So we are having 2 is congruent to 2 modulo 7. We have to reach to 2 to the power 100, but first task is to make this thing as 1. So for that, what I'm doing, I'm simply raising its power to 3. So it will be 2 cube modulo 7. 2 cube is basically 8. But when a number is divided by 7, the remainder cannot be 8. So it will be 1 modulo 7. Whenever the remainder exceeds the divisor, you simply subtract the divisor from that remainder to get the actual remainder, right? So this is 2 cube is congruent to 1 modulo 7. You see, I got the remainder as 1. Now you raise its power to any level, the remainder will still be equals to 1. So now if I go for, because we have to reach 2 to the power 100, so we will be very close if I raise its power to 33. So again, in this case, the remainder will be 1 to the power 33, which eventually gives us 1 itself. So 2 to the power 99 when divided by 7, the remainder is 1. See how quickly we reach 2 to the power 99. Okay. So now we will use property 3 and we will simply multiply this and this. So to get 2 into 2 to the power 99 is congruent to 2 into 1 modulo 7. It means 2 to the power 100 and 2 are congruent modulo 7. It means when 2 to the power 100 is divided by 7, the remainder is 2. Simple? Okay. Let us just keep this thing in our hand. Now let us come for 3 to the power 100. Again, we will start from property 5, that 3 is congruent to 3 modulo 7. Now my prime task is to get the remainder as 1. So what I will do, I will simply raise its power to 2. So it will be 3 square modulo 7. 3 square is 9. 9 cannot be the remainder, so subtract the divisor, that is 7, so we get the remainder as 2. Okay? Now, to get this thing as 1, we raise its power to 3. So this gives us 3 to the power 6 is congruent to 8 modulo 7, but the remainder cannot be 8. So subtract the divisor 7, we get 1 modulo 7. Are you getting the point? Are you getting the point? How I'm interested in finding out the remainder as 1. That's our prime task. So the moment we get 1, now we will be, we have to be close to 3 to the power 100. So for that, I'm raising its power to 16. So it will be 1 to the power 16 modulo 7. 3 to the power 6 to the power 16 gives us 3 to the power 96. Is congruent to 1 modulo 7. Now we got 3 to the power 96, but we have to reach 3 to the power 100. So what I'm doing is I'm simply multiplying the corresponding sides of this 2. No, we have to go to 3 to the power. So we need 3 to the power 4. So let me do one thing. We have 3 squared is 2 modulo 7. So let me raise its power to 2. So it will be 2 square modulo 7. So it is 3 to the power 4 is 2 square, that is 4 modulo 7, right? Now let me just multiply the corresponding sides of this 2. So we are having 3 to the power 4 into 3 to the power 96 is 1 into 4 modulo 7. That's it. So 3 to the power 100 is coming to 4 modulo 7. That is, when 3 to the power 100 is divided by 7, the remainder is 4. Is it clear to all? Now let us come to the last part, 5 to the power 100. So now this I will do because now we are comfortable of this kind of thing. So I will try to do it little fast. You people will understand that. 5 and 5 is congruent to 5 modulo 7. So now let me just raise its power to 3. So we are having 5 to the power cube modulo 7. Now 5 to the power cube is basically 125, right? Now there is a very interesting thing. Listen it carefully. 5 to the power cube is basically 125. But we know that 126 is completely divisible by 7. 126 is completely divisible by 7. So what I will do, I am simply one short of that. We are getting 125. 5 cube is 125. We are one short of that. So in this case, because again I am telling you, my motto is to get that thing as 1. So what I will do here, I will do a little trick. We are actually having 125, but we know that 126 is completely divisible by 7. So in this case, you write your remainder is minus 1 when it is divided by 7. It's all same. I'm telling you why. Because, you see, remainder cannot be negative. That we all know. But here, intentionally we have taken minus 1 because to get 1 actually. But how it is possible, sir? Your remainder cannot be negative. It's okay. We can do one thing. If you want to get the actual remainder, all I will do is you simply add the divisor with it. So it will give us 6 modulo 7. Are you getting the point? This is a very important place. Very important place. Simply divide it, simply add the divisor. You see, when the, the remainder exceeds the divisor, what we do? We simply subtract the divisor. And when it is minus, the remainder is minus, you simply add the divisor to get the actual remainder. But here I am not going to write 6. I am going to write minus 1. Because if I raise its power, if the power is even, the remainder is 1. If the power is odd, then the remainder will be minus 1. And in that case, I will simply add the divisor. So to get the remainder quickly, it's a trick. We must remember that. So in this case, 5 cube is coming to minus 1 modulo 7. I hope you have understood this. Remainder taking as negative. Now what I will do, I have to reach 5 to the power 100. So immediately what I will do, I will simply raise its power to 33. And the moment I raise its power to 33, minus 1 to the power will be 33 modulo 7. So 5 to the power 99 is minus 1 modulo 7. Yes. But we have to reach to 5 to the power 100. So simply I am multiplying this and this, the corresponding sides. So we are having 5 to the power 100 is congruent to minus 5 modulo 7, right? But the remainder cannot be negative, so what I will do, I will simply add the divisor. So 5 to the power 100 will be 2 modulo 7. You see how quickly we got? That is why we will take the advantage of bringing the remainder as either as 1 or minus 1. Okay? So now we have to find out what is the remainder when this thing is divided by 7. So simply I will add the corresponding sides for this equation, for this one and for this one. So we are actually having 2 plus 4 plus 2 modulo 7, right? So we are actually having what? 8 modulo 7. So 8 cannot be the remainder. Therefore, the remainder is 1 modulo 7. Therefore, when 2 to the power 100 plus 3 to the power 100 plus 5 to the power 100 is divided by 7, the remainder is 1. Now, one thing I can tell you, since this is the first sum, that is why we took so much of time. But I can vouch it that while you solve this kind of problems, it will take much less time than the time that we have taken. Because this is our first sum. We have nothing to do. I have to explain each and every step. That's why we have taken so much of time, right? So let us move for the next problem. Now see this question. This question came in JEE Main 2024. And see how quickly we can solve this sum by using modular arithmetic. We have been given 428 to the power 2024 is divided by 21. What is the remainder? So what I will do is, I will simply start with 428 is congruence modulo 21. Now when 428 is divided by 21, what we get? It's 2. 4280. So it is 20, right? So 20 into 21, that gives us 420. So the remainder is 8. This much we can do. Now, if I raise its power to, what is our prime motive? To bring 1 here. To bring 1 in the remainder. So what I'm doing is I'm simply squaring. I'm raising its power to 2. So it will be what? 8 square. 8 square is 64. And when divided by 21, I mean the remainder cannot be 64. So you have to subtract the divisor 3 times here. So 63 will go and the remainder will be, actually the remainder will be 1. So you see, we got it. So remainder is 1 modulo 21. That's it. We have finished the sum. Now, 428 square. We have to reach to 2024. So I'm simply raising its power to 1012. And the remainder will still be equals to 1. Therefore, 428 to the power 2024 when divided by 21, the remainder is 1, and that's your answer. See how quickly we can do it. We can do this sum by using binomial theorem. Okay? But I can assure you that it will not take the time, less than the time we have taken to solve this problem by using modular arithmetic. Isn't it so? Okay, let me take another problem. So this question which came in JEE Main 2023, let the number is 22 to the power 2022 plus 2022 to the power 22. This leaves the remainder alpha when divided by 3. Okay. So let me first solve this. And then we will find out the remainder when it is divided by 7. And we have to find out alpha square plus beta square. It is simple. First, let us find out the remainder when this whole number is divided by 3. Now, let us start with 22. When 22 is divided by 3, what is the remainder? The remainder is 1. Simple. Simple. So, 22 to the power 2022 will be, when divided by 3, the remainder will still be there as 1. So we have found that when 22 to the power 2022 is divided by 3, the remainder is 1. Okay? Now let us come for 2022 when divided by 3. What is the remainder? Let me just do a little calculation here. This much calculation you have to do. So divided by 3. 7 3 is a 21. So 1, 2, oh my God, it is completely divisible. It is completely divisible, right? So that's easy. So when 2022 is divided by 3, the remainder is 0. So when 2022 to the power 22 is divided by 3, again, the remainder will be 0. Therefore, 22 to the power 2022 plus 2022 to the power 22, when divided by 3, the remainder will be 1 plus 0, that is 1. That's it. So here, your alpha is 1. Have you understood this? See how quickly we are solving the sum. So alpha is 1. We got. Now we have to find out beta. Beta is what? The same thing when divided by 7. What is the remainder? So let me start with that. So 22 when divided by 7, the remainder is 1. Therefore 22 to the power 2022 when divided by 7, again the remainder will still be 1. Finished. Next. 2022 when divided by 7, what is the remainder? So now we have to go for this calculation. 7 2s are 14, 62, 7 8s are 56. So it will give us again 6, 2, 7 8s are 56. So remainder is 6 again, right? So, okay, let me do one thing. 288 into 7. That gives us how much? That gives us 2022, remainder is 6. So simply subtract this. We are getting 2016, right? Now, if I add 7 over here, what you are going to have? You are going to have actually, if I add 7, 2016 plus 7. So we are having 2023. Okay. So when 2022 when divided by 7, and if the quotient is 289, the remainder will be minus 1. Have you got it? 289 into 7, that gives us 2023. So it is simply 1 more than 2022. So what you will write? You will simply write minus 1 over here. Now we need that its power to be raised to 22. So again, minus 1 to the power 22 modulo 7. So 2022 whole to the power 22 is, when divided by 7, the remainder is 1. See how quickly we got it. Thus, 22 to the power 2022 plus 2022 to the power 22. If I add the corresponding sides, we are getting 2 modulo 7. That is, when this is divided by 7, the remainder is 2. That is, your beta is 2. So we got alpha as 1, we got beta as 2. Therefore, your alpha square plus beta square is 1 square plus 2 square. That gives us 5, and that's your answer. Is it not a very short, in very short time we are solving this kind of problems? What do you think? Okay, you can do it. Again, I'm telling you, you can do it by binomial theorem, but I can vouch you that the time that will be taken by using binomial theorem will be definitely more than the time we are taking here. That is why modular arithmetic is so very important tool while finding the remainders. Okay, so I hope you have understood this. Let me just give you one sum as your homework. Find the remainder when 2222 to the power 5555 plus 5555 to the power 2222. When divided by 7, what is the remainder? This is your homework. Do this sum and write down your answer in the comment box. See you tomorrow. Till then, take a very good care of yourself.